It's important for software developers to understand object-oriented programming. In this course, Jim from GymShape Coding will teach you all about object-oriented programming in Python.
Object-oriented programming could be what is holding you back from being a great Python developer, and as well as landing your first job as a software engineer. Welcome everyone to Python Object-Oriented Programming course. Now, if you struggle to understand the concepts of object-oriented programming in the past, then you are totally fine and you are in good hands, because in this course, I'm going to make sure that this will be the last tutorial that you will ever watch about classes and the complex concepts that comes with object-oriented programming. And we are going to do this by developing a real Python application that is going to be very cool to write, and we will add to its complexity step by step. And throughout the way, we will understand everything that we need to know about object-oriented programming. Now, there are going to be some requirements to this course. I do expect from everybody to know at least about functions, variables, if statements, and as well as for loops. And if you know those things from other programming languages, then this is also fine. So with that being said, let's get started. Now, to explain why you should write object-oriented programs, I will explain the concepts based on a store management system that we will start developing together. So, starting to think about how to take our first steps with such a program, we could first think about tracking after the items that we have right now in our store. So one way we could get started, we could create those 4 variables to start tracking after our items. So as you can see, we have our first variable item1 equals to phone, and then we have 3 more variables that are intentionally starting with the prefix of item1 so that we could describe that those 4 variables are related to each other by following the correct naming conventions. Now, you might think that those 4 variables are related to each other only because it uses the same prefix of item1. For Python, those are just 4 variables with different data types. So if we were to print the type for each of those 4 variables now, we would receive their types with no surprises, right? We would receive string and integer for price, quantity, and price total. Now, I want to focus on those specific outputs right now because, as you can see, for each of the types, we also see the keyword of class. Now, this means that those data types are actually instances of strings or integers. So in Python programming language, each data type is an object that has been instantiated earlier by some class, and for the item1 variable, that has been instantiated from a string type of class, and for the price, quantity, and price total, those have been instantiated from a class that is named int, meaning integer. So it could have been nicer if we could tell Python that we want to create a data type of our own. It will allow us to write a code that we can reuse in the future easily if needed. Now, each instance could have attributes to describe related information about it, and we can think about at least some good candidates for attributes we could have for our item data type, like its name, price, or quantity. Alright, so let's go ahead and start creating our first class. So I will clean everything from here and we'll go ahead with it. So it is going to be divided into 2 parts. The first one will be the creation of the class, and the second one will be the part that I will instantiate some objects of this class. Now, when I say creating an instance or creating an object, basically I mean to the same thing. So you might hear me saying one of those. Alright, so let's go ahead and say class, and then this needs to be followed by the name of the class that you want to create. So we would like to give it the name of item, and then inside of this class, in the future, we are going to write some code that will be very beneficial and very useful for us, so we won't repeat ourselves every time that we like to take similar actions. But for now, temporarily, I'm going to say here pass, so we will not receive any errors inside this class definition. Alright, so now that we have created our class, then we are allowed to create some instances of this class. So let's go ahead and say item1 is equal to item. And that action is equivalent to creating an instance of a class. Just like if you were to create a random string, then you will say something like the following: this is equivalent to this one as well. So it is very important to understand how classes are working in Python. So I will delete this line because this was just for an example. And now I said that we are allowed to assign some attributes to instances of a class. So let's go ahead and start creating attributes, and that will be achievable by using the dot sign right after the instance of a class. And here you can say that you want to give it an attribute like a name that will be equal to phone, and item1.price could be equal to 100, and item1.quantity could be equal to 5, for example. Now in that stage, you might ask yourself, what is the difference between the random variables that we have created to those 4 lines? Well, here we actually have a relationship between those 4 lines because each one of the attributes are assigned to one instance of the class. And I could prove you this by going ahead and try to print the types of item 1 now, and as well as the types of the attributes of name, price, and quantity. Now with name, price, and quantity, we are not going to have any surprises because we assigned string type attributes to the item object. But if we were to print that, then check out the result if I was to run this program. So you can see that now we have a data type of item here, and that is the big difference between what we have seen previously to this thing that we have just created. So now we understand how we can create our own data types. Now let's go ahead and see what are the rest of the benefits using object-oriented programming. Okay, so until now we understood how to assign attributes to instances. We should also understand now how we can create some methods and execute them on our instances. Now, if we will take as an example the built-in class of string, then you know that we have some methods that we can go ahead and execute for each of our strings. And for this example, you can see that I grab an instance of a string that I named random_str, and then I go ahead in the next line and execute the upper method, which, if you remember, is responsible to grab all the letters and turn them to uppercase. Now, the biggest question here is how we can go ahead and design some methods that are going to be allowed to execute on our instances. Well, the answer is inside our class. So we could go inside our class and write some methods that will be accessible from our instances. So we could go ahead and say def and give our method a name. Now, a good candidate for a method that we'd like to create now is actually calculate total price, because as we understand, it could have been nice if we were to have a method that will go ahead and calculate the result multiplying item1.price with item1.quantity, so we can get the total price for that specific item. Now, before we go ahead and complete this function, then I'm going to just create one more instance of this item by also deleting those 2 lines because we understood the example. So I'm just going to change those to item2 like that, and I'm going to use something like laptop and change the price to 1000 and say that we have 3 of those. Now, just a quick side note, when you will hear me say methods, then I basically mean to functions that are inside classes. Because in terms of Python or in any programming language, when you have isolated definitions with this keyword, then those are considered to be called functions. But when you go ahead and create those functions inside classes, then those are called methods. So that is an important point that you should understand, because I'm going to call those methods from now. Okay, so now if I was to continue by opening up and closing those parentheses, then you are going to see one parameter that is auto-generated that Python wants us to receive intentionally. Now, the reason that this happens, Python passes the object itself as a first argument when you go ahead and call those methods. Now, if I was to go here and say item1.calculate total price, then the action that we are doing now is calling this method. But when you go ahead and call a method from an instance, then Python passes the object itself as a first argument every time. So that is why we are not allowed to create methods that will never receive parameters. Now, you will see this if I was to remove the first parameter and say something like pass. Now, if I was to execute this program now, then you are going to see type error, calculate total price takes 0 positional arguments, but 1 was given. So in simple words, what this exception says is that Python tries to pass 1 argument and you are not receiving any parameter. So that is very problematic. And that is why you always have to receive at least 1 parameter when you go ahead and create your methods. Now, since we always receive this parameter, then it is just a common approach to call this self. It was okay if I was to call it something like my param or I don't know, something else, but you never want to mess up with common conventions across different Python developers. So that is why just make sure that you leave it as self every time. Now, if I was to go ahead and run this program, then you're gonna see that we are not going to receive any errors. So this means that this method has been implemented correctly. Now let's see how we are going to benefit from creating this method, because it should go ahead and create a calculation for us using price and quantity. So I will intentionally receive here 2 more parameters, which we could name just x and y for now, and we could just say return x multiplied by y. And now I will go ahead and pass in here 2 additional arguments, and it will be item1.price. The second one will be quantity. So that is going to work because when you call this method, in the background, Python passes this as an argument, and then it passes this second argument, and then this has been passed as a third argument. So that is perfect. And if I was to run that and actually print this, so excuse me for running this before printing it. So I will surround this expression with this print built-in function, and I will run that, and you're gonna see 500 as expected. Now I could do the exact same thing for calculating the total price of our second item. So if I was to grab this and paste this in this line and actually change this to item 2 and change this one to item 2 and as well as this one, then I would receive 3000 as expected, and that is how you can create a method. Alright, so until that point we understood that we can assign attributes and as well as creating some methods that we can go ahead and use them from our instances directly, like those 2 examples in that line and as well as in that line. Now in that episode we are going to solve some more problems that we have in terms of best practices in object-oriented programming and things that you are going to see in each project that is based on OOP. Alright, so let's get started. Now one of the first problems that we have here is the fact that we don't have a set of rules for the attributes that you would like to pass in order to instantiate an instance successfully. And what that means? It means that for each item that I want to go ahead and create, I need to hardcode in the attribute name like those in here. And it could have been nicer if we could somehow declare in the class that in order to instantiate an instance successfully, name, price, and quantity must be passed. Otherwise, the instance could not have been created successfully. So what that means? It means that it could have been a great option if we could somehow execute something in the background the second that we instantiate an instance. And there is a way that you can reach such a behavior, and that is by creating a special method with a very unique name, which is called _init_. Now you might hear this term as well as called as constructor. Basically that is a method with a unique name that you need to call it the way it is intentionally in order to use its special features. Now the way that this is going to work is by creating it the following way. So it will be _. And as you can see, I already have autocompletion for some very special methods that are starting and ending with _. Now, the collection of those methods are used to be called magic methods. And we are going to learn a lot of more magic methods that you have in OOP, but the first one that we are going to start with will be the init _, like that. Alright, so now that we have created this method, then let's actually see what this method does in the background. So when you go ahead and create an instance of a class, then Python executes this _init function automatically. So what that means? It means that now that we have declared our class, Python is going to run through this line, and then since an instance has been created and we have double underscore init method designed, then it is going to call the actions that are inside this double underscore init double underscore method. Now, in order to prove you that, then I'm going to start with a very basic print here that will say I am created like that. Now we got here one instance and here we got another one. So we should see I am created twice. And in order to avoid confusions, then I'm going to delete those print lines from here so we can see a cleaner picture. Alright, so if we were to run our program, then you can see that we have I am created twice, and that is because Python called this double underscore init double underscore method twice thanks to those two instances that we have created. Alright, so now that we use the double underscore init function in this class, we should take benefit from it and solve some more problems in order to implement OOP best practices. Now, if you remember, in the beginning of this tutorial, I said that one of the problems that we have till this point is the fact that we still hardcode in the attributes in that way by saying .name, .price, .quantity. And that is something that we can for sure avoid. Now, let's see how we can start avoiding creating those attributes hard-coded for each of the instances here. So we can actually benefit from the double underscore init method that we have designed, and let's see how. Now, we understand that for each instance that we will create, it will go ahead and call this double underscore init method automatically. So what that means? It means that not only we can allow ourselves to receive the self parameter, because this is a mandatory thing that we should do, because Python in the background passes the instance itself as a first argument. We could in addition take some more parameters and then do something with them. So as a starter, let's say that we would like to receive one more parameter that we could name it name. And as you can see, automatically Python is going to complain how the name argument is not filled in here. So now I could go ahead and pass in the argument of phone for that one, and for the second one I can go ahead and pass in the argument of laptop. Now, once I have created this, then I can actually go ahead and change my print line a little bit, so it will be a unique print line where I can identify from where each print line came from. So I can go ahead and say an instance created and use a colon here and then refer to the name like that. And now that we have created this, then if we were to run our program, then you're gonna see unique sentences, an instance created for the phone and as well as for the laptop. Alright, so now that we have done this, then there is something that is still not quite perfect because we still pass in the attribute of name here and here. So now pay attention how the init method has to receive the self as a parameter as well, and we already know the reasons for that. And the fact that we have self as a parameter here could actually allow us to assign the attributes from the init method so that we will not have to go ahead and assign the attribute of name for each of the instances we create. So what that means? It means that I can dynamically assign an attribute to an instance from this magic method which is called double underscore init. So if I was to say self dot name, so I'm assigning the attribute of name to each instance that is going to be created or created yet, and I'm making that to be equal to the name that is passed in from here. So what that means? It means that now I can allow myself to delete this line and then this line. So as you can see, now I have a dynamic attribute assignment thanks to this self.name equals name that we have wrote here. And to test that the attribute assignment worked, then I can go down here and use two more lines that will look like the following. So I will print item1.name and I will also print item2.name. And in order to avoid confusions, then I'm going to get rid of this line, so we could only see the print lines from here. And now if I was to run that, then you can see that we receive phone and laptop. So it means that we were able to assign the attributes dynamically, and that is perfect. And now that we get the idea of that, then we should also do the same for the rest of the attributes that we'd like to receive. So we also got the price and quantity to take care of. So I'm going to go to my init method and I'm going to receive again price and quantity, and I'm going to do the exact same thing. So I'm going to assign the attribute of price, and that will be equal to price, and the quantity will be equal to the quantity. And you can also see that again, Python complains about the price and the quantity not being passed in here. So I can say 100 and then 5, and then I can delete those. And then I can do the same here. I could pass in 1000 and then 3 and delete those. And in order to prove you that this is going to work, then I'm going to copy myself a couple of times and change this to quantity, price. This one will be price as well. This one will be quantity, and this one as well. And now if I was to run that, then you can see that the results are as expected. So that is a way that you should work with the double underscore init method. You should always take care of the attributes that you want to assign to an object inside the double underscore init method, meaning inside the constructor. Now a couple of side notes that are quite important to remember when we work with classes. Now, when we go ahead and use the double underscore init method, this doesn't mean that we cannot differentiate between mandatory parameters to non-mandatory parameters. So say that you currently don't know how much you have from a specific item. Then you can go ahead and by default receive this quantity parameter as 0, because it is realistic situation that you currently don't know how much phones you have on your store. So you can directly go ahead and use a default value for that, for example 0, and then this will mean that you will not have to pass in those 5 and 3 here. And now in order to show you the results of that, if I was to run our program, then you can see that we received 0 twice for those two prints in here. So that is something that you want to remember. And one more quite important point that I'd like to talk about now is the fact that you can assign attributes to specific instances individually. So say that you want to know if the laptop has numpad or not, because some laptops are not having the numpad on the right side of the keyboard. But this is not a realistic attribute that you would want to assign to a phone. And that is why you can go ahead and let me delete those print lines, by the way. And that is why you can go ahead and say something like item2.has numpad equals to false, like that. And that is something that you want to remember, because the fact that you use some attribute assignments in the constructor doesn't mean that you cannot add some more attributes that you'd like after you instantiate the instances that you would like to. Alright, so now that we understood this, then there is still one small problem that is left that we need to solve. Now pay attention how the calculate total price still receives the x and y as parameters. And the question that we ask now is why it still receives those parameters. Well, we could for sure now not receive those parameters, because as we know, for each method that we design in classes, then the object itself is passed in argument. And I know that I repeated this couple of times, but this is where I fail to understand classes. So that is why it is very important to understand this behavior. And we already know that the object itself passed as an argument, so that's why we receive self. And so this means that now we could just return self.price multiplied by self.quantity, and this will mean that we don't really have to receive those parameters, because we assign those attributes once the instances has been created. So this means that we have access to those attributes throughout the methods that we are going to add here in this class in the future. So in order to test that this works, then I'm going to delete this example for now, and I'm going to say print item1 dot calculate total price, so we will be able to return the result here. And I will do the same for item 2, only this one. Now to show some real number other than 0, then I will go ahead and pass in here quantities. So I will say 1 and 3, for example, because I don't want to multiply a large number with a 0, and that could come from here. So I will run that, and you see that we receive the expected results. So now we completely understand the big picture, how to work with the constructors in classes, and what are the best practices that you should go ahead and implement. Alright, so now that we understood this, then we might think that we have done everything perfectly. But actually, I want to show you what will happen if we were to pass in here a string besides an integer and run our program. So if we were to run that, then you can see that we are screwing things up here, because this function, for example, thinks that it should print the string 3 times, because you see we have 1000 multiplied by 3 that is being returned in here, so it shows us 1000 once, 1000 twice, and then one more time. So what that means? It means that we have to validate the data types of the values that we are passing in. So there are a couple of ways to achieve this. And one way is by using typings in the parameters that you're declaring inside here. So a great starter will be, for example, to declare that a name must be a string. Now let me first take this back and change those to integer, and then go here and design those parameters. So in order to specify a typing, then you should go ahead and create a colon sign followed by the type of the data type that you expect to receive here. So if I was to pass in here only the object reference to the class of str, then it will mean that it will have to accept strings only. And I can prove you that by changing this to an integer, and you're gonna see that we have a complaint here that says expected type str got int instead, and that is perfect. So now that we have done this, then I'm going to do the same for the price itself. And price, we could actually do the same thing with it by passing in float. Now when we pass float, it is okay to also pass integers, and that is something very unique with floats and integers together. So that is okay to use the typing of float. And for the quantity, we don't need to specify a typing, because the fact that we passed a default value of integer already marked this parameter as to be integer always. So that is why, for example, if I was to leave this as it is and change the quantity to a string, then you're gonna see that it is going to complain because the default value is already an integer, so it expects for an integer. Alright, so those things are actually great setups to make our init function more powerful, but we might still want to validate the received values in the following way. So say that you never want to receive a negative number of quantity and you never want to receive a negative number of price. So that is something that you cannot achieve by the typings in here. But there's actually a great way to work this around, and that will be by using assert statements. Now assert is a statement keyword that is used to check if there is a match between what is happening to your expectations. So let's see how we can get work with assert. So I'm actually going to delete this from here, and I'm going to organize our init method a little bit. I'm going to say here a comment, and I will say assign to self object, and I will say up top something like run validations to the received arguments. Alright, so now it is a great idea to validate that the price and quantity are both greater than or equal to 0, because we probably don't want to handle with those when they are negative numbers and we want to crash the program. So we could say assert, and pay attention that I use it as a statement, not a built-in function or something like that. And I can say here price is greater than or equal to 0. Now once I set this, then I can also do the same for quantity actually. So let me do that quickly by this way. And then once we have this, then I can actually go ahead and run our program, and you will see that I will not receive any errors. But the second that I change this quantity to -1, for example, and this one being -3, then I will have some errors that will say assertion error. Now you can see that the fact that we see here assertion error is quite a general exception that doesn't mean anything. Now what is so beautiful with assert? You can add your own exception messages right near of it as a second argument. So let's go up top here and go back to those two lines. So the first argument that is passed to this statement is the statement that we'd like to check. But if we were to say here comma and use a string to say, actually a formatted string, and I can say price and then refer to the value of it is not greater than 0, like that. I can add an exclamation mark here, and I can use the same thing, copy that with a comma, and paste this in here, and change this quantity, and then refer to the value of it, and say that it is not equal to, greater than or equal to 0. So it needs to be actually changed to greater than or equal to, like that. And same goes for here, and I have some space here that should be deleted. Alright, so now if I was to execute our program, then you can see that we receive assertion error, quantity -1 is not greater or equal than 0. So I should delete this then here for that, and now it is perfect. So now we understand that using the assert statement could allow us to validate the arguments that we receive, and also it allows us to catch up the bugs as soon as possible before going forward with the rest of the actions that we like to take within this program. So let me actually change those back to valid values like that, and that is perfect. Alright, so until this point we learned about how to work with the constructor, and we also learned about how to assign different attributes to instances that are going to be unique per instance, which means that you can go ahead and create as much as instances as you want, and you have the control to pass whatever values you'd like to for the name, price, and quantity. Now consider a situation that you want to make use of an attribute that is going to be global or across all the instances. Now a good candidate for an example of this could be a situation that you want to apply a sale on your shop. So this means that you want to go ahead and having the control of applying some discount for each one of the items. And that is a good candidate for creating an attribute that is going to be shared across all the instances. Now we call those kind of attributes class attributes, and the kind of attribute that we have learned till this point is actually called in a full name instance attributes. So about instance attributes we know everything and we learned how to work with it, but we did not work it with the other kind of the attributes, which we will do in this tutorial, which is called again a class attribute. So a class attribute is an attribute that is going to be belong to the class itself, but however you can also access this attribute from the instance level as well. Let's go ahead and see a good candidate for a class attribute that you want to go ahead and create it. So that's gonna be going to our class here, and just in the first line inside our class I can go ahead and create a class attribute. So let's go ahead and create an attribute like pay rate equals to 0.8. And the reason that I'm doing this is because I said that there's going to be 20% of discount. So I probably want to store an attribute that will describe how much I still need to pay. So I will say here the pay rate after 20% discount, like that. Okay, so now that we have created this, then let's see what are the ways that we can access this attribute. Now if I was to go down and actually deleting one of those and say something inside this print line that will look like the following. So I will try to access to the reference of the class itself. So I'm not going to create an instance like that. Besides, I'm just going to bring in the reference to the class level itself. And I'm going to try to access this attribute by saying pay underscore rate. Now if I was to run that, then you're gonna see that as expected we see this class attribute, because that is a way that you can access those class attributes. Now this might be confusing, but I said a minute ago that you can also access those class attributes from the instance level. Well, let's see if that is true. So if I was to duplicate those lines twice by using the shortcut of Ctrl D, then let's go ahead and change those to item 1 and this one to item 2. Now see how I try to access the pay rate attribute from the instance, although we don't have such an instance attribute. Now if I was to run that, then you're gonna see that we still have the access to see that class attribute. Well, that might be confusing and that might be hard to understand why that is happening. Well, there is actually something that we need to understand when we work with instances in Python. So when we have an instance on our hand, then at first this instance tries to bring the attribute from the instance level at first stage. But if it doesn't find it there, then it is going to try to bring that attribute from the class level. So what that means? It means that item 1 did some thinking here and say to itself, okay, so I don't have this attribute right in here because that is just not an attribute that assigned to me. So I'm going to try to search that from the instance level, and then I'm going to find it and print it back. So that is exactly what is happening here. Item 1 and item 2 are instances that could not find the pay rate attribute on the instance level, so both of them went ahead and tried to bring this attribute from the class level, and since it really exists in the class level, then we were able to access those. Now, to even give you a better idea of what is going on here, then I'm going to do one more additional thing. Now I will delete this first print line, and I will go ahead and delete those attributes from here as well. Now there is a built-in magic attribute, not a magic method, that you can go ahead and see all the attributes that are belonging to that specific object, and that is achievable by using this double underscore dict double underscore like that. So this will go ahead and try to bring you all the attributes that are belonging to the object that you apply this attribute and want to see its content. So I will go ahead and copy this one and paste this in for the instance level as well. So this should give me all the attributes for class level, and the second line should do this for the instance level. Alright, and if I was to run that, then let's explore the results for a second. Now you can see that at the first line we see this pay rate attribute, but in the second line we never see it. We see name, price, and quantity. And you can also pay attention that this magic attribute is actually responsible to take all the attributes and convert this to a dictionary. And that is from where the dict keyword coming from. It is just a shortened version of a dictionary. So that is a very useful magic attribute that you can go ahead and use if you just want to see temporarily, for debugging reasons, all the attributes that are belonging to some object. Alright, so now that we understood this, then let's take it to a real life example and come up with a method that will go ahead and apply a discount on our item's price. So that will be by creating a method that will belong to each of our instances. And that means that we can go ahead and come up with a method that we could name apply discount. So let's go ahead and start working on this. So I'm going to say def apply discount, and pay attention that I'm using a new method inside a class here. So right inside of this, then at first we need to figure out how we are going to override an attribute that is belonging to an instance. And we already know that we can do that with the self keyword. So it will be self.price, and that will be equal to self.price, meaning the older value of this attribute multiplied by the pay rate. Now you might expect that we could access this directly like that, but if you remember, that is actually belonging to the item class itself. Now this might be confusing because this method already inside this class, so you might think already that you can access it directly by saying pay rate because it is already inside the class, but that is actually not going to work because you can either access it from the class level or the instance level as we understood previously. So I can go ahead and say item.payrate like that, and there you have a method that can go ahead and basically override the price attribute for one of your items. Now to show you that this works, then I can only use one instance for now, and I can go ahead and call this method by say apply discount, and I can also now try to print the attribute of price for this item 1, and we should see 80, right? So if we were to run that, then you're gonna see that we are going to receive 80.0 as expected. Now we should not forget the option that you might also want to have a different discount amount for a specific item. So say that one day you'll have 20 items and only for the laptop you want to have a 30% discount. But it is going to be a bad idea changing the class attribute to 0.7 because it will affect all the items that you have right now on your hand. So what you can do instead is you can assign this attribute directly to one of the instances that you would like to have a different discount amount for. So let's go ahead and see an example for this. So I will allow myself to bring back the item of laptop, and then what I can do to apply a 30% discount for this item is assigning the exact same attribute to the instance. So I can go ahead and use a item2.pay_rate is equal to 0.7. Now what will happen here is that for item2 it will find the attribute of pay rate in the instance level. So item2 does not really have to go ahead to the class level and bring back the value of pay rate, because at first look it is going to find it in the instance level. But for item1 it is different. It is still going to read from the item level, which is going to be 0.8. So now if we were to try to use item2.apply discount and as well as printing the price now, then let's see what will happen. So I will uncomment this line to not see this print for now, and I will go ahead and execute our program. Now you can see that we still, however, receive 800. And what this means? This means that the discount that has been applied is still 20%. And where this is coming from? Well, this is coming from this method here, that no matter what, we try to pull the pay rate from the class level. So a best practice here will be to change this to self. And that way, if we override the pay rate for the instance level, then it is going to read from the instance level. But for item 1, if we try to access the pay rate from the instance level, then this is still great because we did not assign a specific pay rate for item 1, so it is going to pull that from the class level. Now if we were to try to run that, then you're gonna see now that we have expected results. And if we were to also uncomment the first print line for the item 1 and rerun our program, then you can see that for item 1 we had 20% discount, and for item 2 we had 30% discount. So when it comes to accessing class attributes, you might want to reconsider how you want to access them when you come up with some methods. And specifically for creating a method like apply discount, it is a great idea to access it from the instance level, so you also allow the option of using a pay rate that is assigned to the instance level. Okay, so now that we understood completely about the differences between a class to an instance attribute, let's jump ahead to the next topic. Now you see that I have deleted those print lines that I have down below, and I came up with 5 instances that I have created here. So you might also want to create those 5 instances immediately, so that is why I will recommend you to go ahead to my repository, accessing this class attributes directory, and then code snippets, and then go ahead and copy the code from this 5_items.py file. Okay, so considering a situation that your shop is going to be larger in the future, meaning that you are going to have more items, then the more items that you are going to have, the more filtration-alike things that you want to do in the future. But what is problematic currently with our class is the fact that we don't have any resource where we can just access all the items that we have in our shop right now. Now, it could have been nicer if we could somehow have a list with all the item instances that have been created until this point. But currently there is not an approach that will give us a list with 5 elements where each element will represent an instance of a class. So in order to come up with such a design, then here is a wonderful candidate for creating a class attribute that we could name all. And once we do this, then we're gonna see how we are going to add our instances to that list. So I will go ahead and start by going here and use an all attribute. So it will be all equals to an empty list. Now we need to figure out how we are going to add our instances for each time that we are going to go ahead and create an instance. Now if you remember, the double_init method is being called immediately once the instance has been created. So it might be a wonderful idea going down below inside this double_init method and use a code that will be responsible to append to that list every time that we create an instance. And that will be as easy as saying something like the following. So first, you could pay attention that I actually wrote some commands in this double_init function, like run validations and assign to self object. So it might be a great idea to start with a comment here that will say actions to execute, just to really have a great separation between the different things that we are doing. So now inside here I can say item.all, and you can see that I use the class object first, and then that is a list, so I can use .append, and then I will just append the self object. Now we know that self is actually the instance itself every time that it is being created. So once we go ahead and launch such a command inside the init function, then for each instance that is going to be created, this all list is going to be filled with our instances. Now to show you that, I can jump a line after we create the instances, and we can say print item.all. And now if I was to run our program, then you are going to see that we're going to have a list with 5 instances. If I was to scroll right a bit, then you can see that I have exactly 5 elements, and that is perfect. Now that's going to be extremely useful if you want to do something with only one of the attributes of your instances. So say that you'd like to print all the names for all of your instances, then you can use easily a for loop to achieve such a task. So you can go ahead and say for instance in item.all, and you can say print instance.name. And once we come up with this, then you can see that we have all the names for all the instances that we have created. So that is going to be useful here and there, especially if you know how to use the filter function, for example, to apply some special things on some of the instances that are matching your criteria. Alright, so now that we understood this, then let's also take care of one problem that we saw previously. Now, if I was to use a Ctrl-Z a couple of times and still use this print item.all, now you could see that the way that the object is being represented is not too friendly. Now, it could have been nicer if we could somehow change the way that the object is being represented in this list here. Now there's actually a way to achieve this by using a magic method inside our class. Now there is a magic method that is called _repr, and repr stands for representing your objects. So that is why you can actually go ahead and use this magic method, and then you will have the control to display your objects when you are printing them in the console. Now I actually recommend watching a video that compares between a method that is similar to it, which is called _str, and you can take a look in the description of this entire series to actually watch the video that I'm talking about. Alright, so let's go ahead and use the repr method to understand how this is going to work. So I'm going to say def inside our class, and I'm going to use _repr_, and as expected it will receive the self. Now what we can do now is returning a string that will be responsible to represent this object. Now obviously we don't want to use something that is not unique for each of the instances, because say that I was to use now return item, something like that, and run our program, then you can see that I'm going to receive a list with this string 5 times, but it is going to be hard to identify which instance represents each string here. So it could be helpful if we were to return a string that could be unique. So I'm going to close the console here and go ahead here and use a formatted string, and in order to make this unique, it is a best practice to represent it exactly like we create the instance like that. So what I'm going to do here is leaving the item and use a brackets opener and a closure, and then I'm going to make the return string here as much as equal as possible to the way that we create those instances. So I will start by typing here single quotes to escape from the double quotes that are coming from here, and I'm going to refer to the value of name by using self.name, and then I will leave my single quotes and I will use a comma like that, and then I will go ahead and refer to the value of our price. I will use one more comma and I will say self.quantity. Now if we were to execute our program again, then you can see that now we receive a list that is way more friendly than what we have seen previously. And you can also see that this first element, for example, is quite equivalent to this line here. Now you might be curious why I worked so hard to return the representative version of our objects the same way that we create them. So that is just a best practice according to Python's documentations, because it will help us to create instances immediately by only the effort of copying and pasting this to a Python console. So if you think about it right now, if you open a Python console and you import this class, then it will be as easy as grabbing this and pasting to the Python console, and then you will have an instance being created. So that is the single reason that I have came up with this approach. And also for sure I just wanted to return a unique string that will really represent our instance. And you can see that it is very easy to identify the instances of our class with this list and with this approach. Alright, so until this point we understood how we can change the way that we represent our objects, and we also understood how we can access to all of our instances by this class attribute that we intentionally named all. Now in this part we are going to take a look to solve one more problem that we have in terms of best practices when we are going to extend this application and add more features. Now you can see that until this point we maintain our data as code in this main.py file by only instantiating those 5 items. Now when we will look to extend this application and add some more features, then we might have a harder life to add those features because the actual data and the code are maintained in the same location, meaning in the same main.py file. Now you could have think about creating a database that will maintain this information, but I want to keep things more simple for the purposes of this tutorial, and that is why I'm going to use something that is called CSV that you might have heard of. CSV stands for comma separated values. So this means that you could go ahead and use a CSV file and you could store your values as comma separated, where each line will represent a single structured data. And CSV is a great option here because it allows the data to be saved in a table structured format. Alright, so let's go ahead and create a CSV file, and I will actually go ahead and name this items.csv like that. And I will go ahead and paste in some CSV content that will be responsible at the end of the day represent the same data that we look to have here. So you can see that at the first line I have name, price and quantity, and you can see that those are comma separated. So those represents the columns that we are going to have as the data that we are going to maintain, and in the second line and further we are going to have some data that will represent the actual data that we look to maintain. So if we were to now split the panes, then you can see that those are quite equivalent, and now we should only look for a way to read this CSV file and actually instantiate those objects. Now you can see that I have a suggestion by PyCharm to install a plugin that will support CSV files. So I'm going to just click on that and install those plugins. And you can see that I will have a CSV reader here, and we will see if we will be able to see this data in a table, which will be a lot nicer. So let's go ahead and install this. And now you can see that I have some more options that I can actually go ahead and use from here. I know that this is quite small, but actually you have some tabs that you can go ahead and click on them. And if I was to click on table editor and actually give this file more focus, then you can see that I actually have the best way to read this data now. You can see that I have my columns, you can see that I have my rows, and that is quite nice. Now I can really go ahead and visualize my data more nicer, and it is just more common way to maintain your data. Okay, so now that we understood how CSV files are working, let's go ahead and read our CSV files and instantiate the instances in a generic way. So it makes sense to delete those 5 lines, and I'm going to use those lines below the apply discount and use a method that I could name instantiate from CSV like that. Now you can see that this one is also going to receive self, because if you remember, I said that in each method that we will design, we need to receive at least one parameter that will be passed as the instance itself, because this is how Python OOP works. Now the problem is, we are not going to have any instances on our hand to call this method from the instance, because this method is actually designed for instantiating the object itself. So this means that this method could not be called from an instance. So the way that this is going to be solved is by converting this method into a class method. Now a class method is a method that could be accessed in the following way. So I will use this line to delete that, and it could be accessed from the class level only. So this will look like item.instantiate from CSV, and then in here we will probably pass our CSV file. So this method should take full responsibility to instantiate those objects for us. So now that we understood this, let's go ahead and see how we can create a class method. So for sure we need to delete the self, and I know that we have errors, but we are going to solve each one of those just in a second. Now in order to convert this to a class method, we need to use a decorator that will be responsible to convert this method into a class method. Now decorators in Python is just a quick way to change the behavior of the functions that we will write by basically calling them just before the line that we create our function. So we could use the @ sign and use the class method in here, and then this instantiate from CSV method will be a class method. Alright, so now that we understood this, then we should also understand one more piece of information before we go ahead and design this method. Now I want to show you what will happen if I was to delete the entire name and try to recreate this function here. And I will just say instantiate from CSV again. Now pay attention what will happen if I was to open up and close the parentheses. Now you can see that it still receives a parameter, but this time it is named CLS. Now what is going on here? And the thing that is going on here is the fact that when we call our class methods, then the class object itself is passed as a first argument, always in the background. So it is a bit like the instance where it is also passed as a first argument, but this time when we call a class method in this approach, then the class reference must be passed as a first argument. So that is why you should still receive at least one parameter, but we probably understand that we could not name this self because that is just going to be too much confusing. Okay, so now let's go ahead and write some code to read the CSV file and instantiate some objects. Now I'm going to go up top first, and I'm going to import a library that is called CSV. So I will go here and I will use an import CSV line, because that will be the library that will take full responsibility to read the CSV file, and then we will see how we can instantiate some objects. Alright, so now I can go ahead and use a context manager to read the items.csv file. Now both of those files are located in the same location, so I can just directly say with open items.csv, and the permission that I will be passing here could be R, because we only look to read this, and I will say as f like that. Now inside this open, I will go ahead and use some method to directly read this CSV, which at the end of the day will be responsible to convert this into a Python dictionary. So I will say reader is equal to csv.dict reader, like that, and I will pass in the content of our file like that. Now this method should go ahead and read our content as a list of dictionaries, but at the end of the day we should also go ahead and convert this into a list. So I will go ahead and create one more variable that will be equal to items, and I will just convert the reader into a list, and that's it. And now that we have completed the actions that we wanted to complete by reading this CSV file, let's go ahead and use a shift tab to indent out. And now before we go ahead and instantiate some objects, let's go ahead and see the results of iterating over the items list. Now I will go ahead and use for item in items, and then I will just use print items to show you the behavior of that. And excuse me, it should be item. Alright, so now that we understood this, then let's go ahead and see what we have in those lines. So after our class definition, we only go ahead and call this item.instantiate from CSV method. So if I was to run that, then you can see that I receive some dictionaries in separated lines, and that is because I iterate over a list of dictionaries in here, and that is just perfect. Alright, so the only thing that we miss right now is creating instances. Now, besides printing those, then we could now say something like item and open up and close parentheses, and this should be enough to instantiate our instances. Now, I can go ahead and pass my arguments in here by basically reading the keys from a dictionary. So I can say name is equal to item.get, and that will receive name. And now I can add a comma and duplicate this line twice and change those accordingly. So this will be price and this will be quantity. And now I need to replace my key names. So it will be price here and then quantity right there. And now let's go ahead and see what will happen if I was to call this method and as well as calling the attribute of item.all. Because this one stores all the instances inside the list. Now if I was to go ahead and run it, then you can see that I have some errors. Now you see that the errors are related to the price, and you can see that we receive is not greater than or equal to 0. Now let's go ahead and fix this very quickly. So in the items.csv, you can see that those are actually integers that are greater than 0. So the problem is probably the fact that those are passed as strings. So we need to go ahead and pass those as integers. So I'm going to convert those into int like that. And now let's go ahead and see if we will have any problems, as I expect to have any problem, because the quantity should complain about the same thing. And you can see that this is exactly what is going on here. So I can use the same for quantity like that and work with that. And you can see that now we see our instances perfectly. Now I want to show one more problem that we could have in the future and we should avoid now. So those three lines are going to work with this structure of a data. But if I was to change the price of our keyboard to something like 74.90, something like that, and re-execute our file, then you can see that we will receive some problems. So we need to convert the price not to an integer but to a float like that. And that is the only way to get over this, because we don't want to convert the price to an integer directly because it could be float. So now we could go ahead and execute, and you can see that now it works perfectly. Although we see the prices as 100.0, but that is something that we will look into it in the future, but for now it works perfect. And now we are ready to jump on to our next topic. Okay, so now that we completely understood class methods, let's go ahead and also understand what static methods are. Now, a static method should do some work for you that has some logical connection to a class. So, for example, if you want to check if a number is an integer or a float, then this is a good candidate for creating a static method, because this has some connection to the class that we work with. So it makes sense to check if a price of an item has a decimal point. And by saying has a decimal point, I obviously count out those that are 0.0. Now, to be honest, static and class methods could look very alike to you, but we will explain the main differences very soon. Okay, so I will use those lines to create our first static method. Now, let's go ahead and use the def keyword, and we will name this method is_integer because we said that we'd like to write a static method that will check if a received number is an integer or not. Now, if I was to open up and close parentheses, this would obviously receive self. Now, I want you to take a closer look. what will happen if I was to change this method into being a static method? And the approach is going to be pretty much the same like we have done with the class method. We will use a decorator that is called static method, and this should be responsible to the conversion. So I will go ahead and use this line, and I will say at static method like that. Now pay attention how the received parameter turned into the regular orange color that we are familiar, because that is just a regular parameter that we receive. Now this means that the static methods are never sending in the background the instance as a first argument, and that is unlike the class methods. The class methods are sending the class reference as a first argument, and that is why we had to receive the CLS, and that is why it is intentionally colored with purple. But with static methods, we never send the object as the first argument. So that is why we should relate to the static method like a regular function that just receives parameters, like we are familiar with isolated functions. Now I will go deeper on this just in a few minutes, but let's go ahead and finish up our static method first. So this should receive num as one parameter, because we should receive at least something to check if it is an integer or not. Alright, so now that we are inside this method, then I can go ahead and use a couple of if statements to check if the received argument is an integer or not. Now if you remember, we said that we will count out the floats that are decimal, that are 0.0, okay? Meaning, for example, 5.0, 10.0, and so on. Alright, so now that we understood this, let's go ahead and use an if statement here. So if, and we will call the built-in function that is called isInstance, and this should receive two arguments. And we can understand what this function is going to do for us. It is going to check if the received parameter is an instance of a float or an integer. So we will pass in as the first argument the num, and as the second argument the float without calling those parentheses. So only the reference to the float keyword. So this conditional should go ahead and check if the num is a floating number or not. Now inside this if statement, I will say return num dot is integer. So by saying dot is integer, then I basically say count out the floats that are decimal, that are 0.0. So this means that if I was to pass in here a number like 10.0, then this will return false. But remember that this will enter here because it thinks it is a float, because it is represented in that way. And so the is underscore integer should check if the point is 0 and should return false accordingly. Now I will also use an else if statement here to basically check if it is integer by itself. So I will say elif is instance num and check if it is an instance of an integer. Then I will just return true. And if it is just something else, then I will just say return false, like that. So now that we have designed this method, then let's take a look how we can call it. So now I will just remove this and this. I'm not actually going to instantiate anything. I'm just going to show you how you can access to the static method. So I will just call this item.isInteger, and I will just pass in a number that I would like to check if it is an integer or not. Now for sure we like to print this, so we will see the result. Now let's go ahead and pass in 7. So you can see that we receive true. Now if I was to pass in 7.5, then I would receive false. And what is happening in the background? It is the fact that it enters here, but it sees that it is not an integer, so it returns false. But if I was to change this to 7.0, then this should, sorry about that, this should still return true, because what is happening? It is entering inside this conditional, and then it checks if it is an integer, but we said that this method counts out the floats that are 0.0, so it returns true still. So that is a perfect design. Alright, so I have came up with a new file which I will just explain here when to use a class method and when to use a static method, so we can completely understand the differences between those, because I remember myself, I had a very tough time to understand why I need this and why I need the other one. So that will be the main question that I will be answering in this Python file, so don't feel like you have to copy and paste the code. Following along what I am explaining here by listening should be enough. Alright, so in this file, I will just go ahead and create this class item that we have, right? And I will use pass to not receive errors. Now, when we will use a static method, so we will use a static method when we want to do something that should not be unique per instance, exactly like we have done previously. So isInteger is a method that is just going to be responsible to check if a number is integer or not. So that is why I could allow myself to include this under the item, just like I could use this def as an isolated function right above the class, and that was also okay. But I prefer to not do that, because although this is a method that has nothing to do with instance, that is somehow related to the item class. So that is the reason you want to create this as a static method like we have designed previously. And the reason that you would like to create a class method is for instantiating instances from some structured data that you own. So exactly like we have done, we have created a class method that was responsible to read the CSV file and creating some instances. So as I wrote here, those are used to manipulate different structures of data to instantiate objects, like we have done with the CSV file. We could also use a class method like instantiate from a JSON file or from a YAML file. Those just are different ways to maintain data in the best practice way. And that is the code that you look to include inside your class methods. That is why they should be existing in any class, especially if you look to instantiate hundreds of objects on your programs. So it is a great idea to have at least one class method like we have done in the item class. Now, the only main difference between a class method and to a static method is the fact that static methods are not passing the object reference as the first argument in the background. It is noticeable from the fact that we don't have a special highlight, purple in my case, for the first parameter. So if you remember, if I was to go ahead and use here a first parameter like num, then you will see that this is a first parameter that is colored with orange because that is a regular parameter. But that is purple because this is a mandatory parameter that we should receive because what I have just explained. So those are the main differences between a static method to a class method. Now if you remember, I intentionally said that the class methods and the static methods could only be called from the class level. But however, those also could be called from instances. So as you can see, I can actually instantiate an object and call the isInteger, and as well as the instantiate from something. You can just pass in here a number like 5 and I will not receive any errors. And if I was to run the helper, then you can see that I don't have any error. Now, I'm going to be honest with you, I never saw a reason to call a static method or a class method from the instance level. But that is just an option that exists. I know that it is very confusing, but that is something you are rarely going to see. And like I said, I never saw a great reason to call a static method or to call a class method from an instance. So my recommendation to not confuse you is just not going with calling those from the instance level. Alright, so I minimized the code that we wrote so far in the class item. Now, in order to start solving the problems that we will solve in this episode, then I'm going to create here two instances. So I will say phone1 is equal to an item, and let's give it a name like JSC phone v10, and then just use a random price and quantity, and I will copy and paste this and use another variable like phone2, and I will increase the version by 10, and let's say that this price for the phone2 should be 700. Alright, so now that we have created two instances of a phone, pay attention that those two items are phones. So we could think about some attributes that could represent phones in real life. think about an attribute like broken phones, because we could have some phones that could have been broken, and so we cannot really mark it as a phone that we could really sell. So this means that we could go ahead and say phone1.brokenphones. Let's say that we have, unfortunately, one broken phone on our hand right now. So I will go ahead and assign the same attribute for our second phone. And now that we have came up with this realistic attribute, then the next step that we might think about could be creating a method that will go ahead and calculate the phones that are actually not broken, meaning subtracting the quantity by the broken phones amount, because this is totally making sense, and then we can understand what are the phones that we could go actually and sell them in the future. But we have a couple of problems creating a method that will go ahead and calculate such a thing, because we cannot really go ahead inside our item and do this smooth enough, because we don't really have the broken phones attribute assigned to self, and we cannot actually go ahead and create this method inside this item class, because this method is not going to be useful for other hundreds of items that you will go ahead and create. This just represents a phone kind of item. So in order to solve this problem in terms of best practices in object-oriented programming, then we could go ahead and create a separated class that will inherit the functionalities that the item class brings with it. And that is exactly where we could benefit from inheritance, and we could go ahead and create a separated class that we could name phone, and then this phone class will inherit all the methods and all the attributes that item class has. So let's go ahead and simulate that. So I'm not going to delete the instances yet, but I'm going to go ahead here and create a class that I will name it phone. Now pay attention that I will not use a semicolon, and I will use those brackets, and I will specify what class I would like to inherit from. So I will inherit from item, and then I will just use a pass temporarily, because I would not like to use additional functionality right now inside this class. Okay, so now that we have created this class, then let's go ahead and first execute our program, where at the first stage the instances will be item instances. And this should not have any problems, because we know that we can create those item instances and we will not receive any errors. But if we were to change those to phone like that, then we should still not receive any errors. And that's just a basic way that you could use inheritance in order to represent different kinds of objects when you want to do that. Now, this could also be applied to other realistic programs that you want to come up with them by your own. But in my case, it totally makes sense to create some classes where each class will represent a kind of an item, and then I could go ahead and inherit from the item class in each of the child classes that I will go ahead and create in the future. I could also use another class for a kind of item like laptop, and then I could go ahead and use a separated functionality for that. Now, when we talk about classes that we inherit from, then those are considered to be called parent classes. And when we use multiple classes that inherits from that parent class, then those are considered to be called child classes. So those are just terms that you want to be familiar with when we talk about object-oriented programming, and from here we will see more advanced things that you can go ahead and do with your child classes. Alright, so now let's go ahead and understand some more advanced things about inheritance. Now, throughout this series, we learned that it is not a great idea to assign attributes manually once we create those instances. And the better way to do that is actually going ahead and creating our constructor and pass the value that we'd like to immediately in the instance creation, exactly like here. So in order to solve this, then we're gonna need to figure out how we are going to do that, because creating the constructor inside this phone class is going to be a little bit tricky, because we don't really want to break the logic that the double_score init brings with the parent class, but we'd also like to pass in an additional attribute like broken phones that we will go ahead and deal with that attribute and assign it to the self object exactly like we have done in the second part of our series. So in order to keep the logic the same for this child class and as well as receive some more attributes, then for now I'm going to go ahead and copy the code in our constructor and just paste this in right inside our phone class. And that's making sense temporarily because we receive the exact same parameters that we should receive when we instantiate an instance, and we also have now the control to receive some more parameters like we want to do with the broken phones. So let's go ahead here and say broken. So I will just scroll here and I will say broken phones is equal to 0. Let's also receive a default value for that. And let's go ahead and type in a validation for the broken phones. So I will allow myself to just copy that and paste this in, and we'll use assert quantity, broken phones is greater than or equal to 0, and I will change this to broken phone like that, actually broken phones, and this should be exactly like we have done with the quantity. And now let's go ahead to the section of assign to self object, and we can use self.broken phones is equal to broken phones like that. And you can see that here we have actions to execute. Now it could have been nicer if we could also create a class attribute for the phone class, and that will mean that we could go ahead here and say all is equal to an empty list, and then we could go ahead and use a phone.all.append like that. And now if I was to go ahead and run this program, then you can see that I will not receive any errors. Now to check that this works, then I'm also going to pass in here 1, and I'm going to do the same here as well, and I'm going to remove those. Alright, I'm going to remove the hard-coded attributes, and the program still works. Now I'd also like to test this by applying one of the methods that we have wrote so far, and that will be obviously a method that I'd like to use from the parent class because we inherit those methods. So I can go ahead and use phone1.calculate total price, and it makes sense to print this. So I will go ahead and print that, and you can see that print phone1.calculate total price. And now if I was to run that, then you can see that I receive a result. So this means that I don't have any errors. Now I'm not sure if you paid attention to this, but if I was to scroll up a bit, then you're gonna see that the constructor in the child class is complaining about something. And let's hover the mouse and see what is the warning. Now you can see that it says to us call to _init of super class is missed. And what that means? It means that when we initialize the _init method inside a child class, then Python expects for some function to be called intentionally. Now this function is named super, and what super allows us to do, it allows us to have full access to all the attributes of the parent class, and by using the super function we don't really need to hard code in the attribute assignment like we have done with the name, price and quantity, and as well as for the other validations that we have executed every time that we want to come up with a child class. Now imagine how hard that is going to be if for each of the child classes that we will create in the future we will have to go through copying and pasting assert price and quantity, and as well as doing the assign to self objecting in those 3 lines. That is going to be a lot of duplication of code. Now to save us that time, that is exactly why we need to use the super function. The super function will allow us to have the attributes access from the parent classes, and therefore we will be able to fully implement the best practices in inheritance when it comes to object-oriented programs. Now again, this program works because we assign the attributes of name, price and quantity for the self object in the child class. But if I was to remove those 3 lines and as well as those 2 lines, now those lines happen to be the lines that I have copied and pasted, and try to run this program, then you can see that we receive attribute error phone object has no attribute price. And pay attention from what line it comes from. It comes from line 21 from the item class, because it thinks that it has the attribute of price, but we never have the price attribute in the phone level because we just deleted the self.price is equal to price, and that's why now we have some problems. And we are going to replace all the lines that we have deleted with the following thing that I'm going to just execute now. So I'm going to go to the first line of our constructor and I'm going to say call to super function to have access to all attributes slash methods. And then I'm going to say super. Then I'm going to open up and close parentheses. And then I'm going to use the double underscore init method like that. Now you can see that the second that I have completed this, then there are no more warnings about the constructor in this child class. And you can also see that this double underscore init method expects for some special arguments. Now those special arguments obviously coming from the item class that we inherit from. So if I was to pass in here name and also price and also quantity, then this should be fine. Now you can also ask yourself, isn't it a duplication of code? The fact that we also copied and pasted the parameters that we receive in the child class? And yeah, that is a perfect question. That is something that could be solved by something more advanced. If you heard about keyworded arguments, that is something that we can solve it with that way. And then we will not have to duplicate the parameters that we receive for the constructor, but that is not something that I'm going to show for that stage. I'm going to stick with it and I'm just going to leave it as it is. Now, calling the super function and as well as the init method right after it should be responsible to have the same behavior like we had previously. So we should still see 2500 for this print line and we should not see any errors. And if I was to run the program, then you can see that we receive the expected result. So that way we implement the best practices of object-oriented programming. For each child class that we use a separated constructor, we also gonna need to call the super function in order to have fully access for all the attributes and methods that are coming from the class that we inherit from. Alright, so I minimized the code for our classes and I also left with one instance of phone here. Now I want to show you the results of the following things. So I will say print and I will see what is the list of all in the item class is going to bring us back. So I'm going to say item.all and then I'm also going to say phone.all. If you remember, we implemented this class attribute as well here. So I will minimize the code back and then I will run our program. Now you can see something very weird in here. We see item and then we basically see the result of the REPR method that comes from the item class. Now the reason that this happens because we never implemented an REPR method inside the phone class, so that's why we see this ungeneric result of item. Now you can also pay attention that we only create an instance of the phone class, so that's not so good that we see item in those outputs. So what we could use instead of hardcoding in the name of the class in the REPR method inside the item class, then we could access to the name of the class generically. Now if I was to replace this with some special magic attribute that will be responsible to give me the name of the class, then this will be perfect. So I'm going to delete that and I'm going to use curly brackets and I'm going to say self dot double underscore class dot double underscore name. So that is a generic way to access to the name of the class from the instance. And by doing this, then besides receiving item hard-coded string, then I should receive the name of the class that I initialized from the very beginning. So this should be phone, because that is the only single instance that I have right now. And you can see that this is exactly the result that I'm receiving back, so that is perfect. Now I said earlier that by using the super function, then we basically have access to all the attributes and the methods that are coming from the class that we inherit from. So what that means? It means that we will also have the access to the class attribute of all that is inside the item class. And I'm talking about that attribute. Alright, now to show you that, then I'm going to open back the code from the phone class and I'm going to remove the all attribute. And I'm just going to do that right now. And I'm also going to delete the actions to execute where I use phone.all.append because we no longer having the all attribute in the phone class. And if I was to remove those and execute our program now, then you can see that I still receive the same result. So that is a great idea, removing the old attribute in the child class level. It is a great idea to only use the old attribute in the parent class, because by using the super function in the child class, we will have access to the old attribute. So this means that if one day we'd like to have access to all the items instances that have been initialized, including the child classes, then accessing them from item.all should also be enough. Now you might be confused how this line is responsible to add this instance inside the all attribute that is happen to be a list. And that's happening because by using the super function and as well as the init, then we basically call the init method inside the parent class. Now in the latest line inside this method, we also use item.all.append, which is also going to be accessible from the phone class. So that's why calling the all class attribute from the item class is a better idea, because it will give us the complete picture. Okay, so before diving into the topic of that episode, then we're gonna need to do some code organization in here, because as you can see, for each of the child classes that we will go ahead and create in the future to extend this project, then we're gonna need to do this in the main.py file, because that was the only single file that we were working with. And now that our project grows, we need to start working with multiple files. So that's why maybe working with a file that will represent the class of item and working with a separate file that will represent the phone child class will be a better idea. So we will have the main.py file dedicated for only creating instances of those classes. So let's get started with this. So I'm going to go to the project directory and create two Python files. First one will be named item.py. The other one should be named phone.py. And I'm going to take the code from our item class, and I'm just going to grab everything like the following, and I'm going to cut this, and then I'm going to paste this inside of that. Now pay attention that I use the CSV library, so that's actually the location that I need this library. So I'm going to just copy the import line, and that should be good enough. Now I'm going to do the same process for the phone.py, and I'm going to be copying this into the phone.py file as well. But now this file needs to import the item class, because as you can see, we got an error here. So we should say from item import item like the following, and the errors should be gone. And then in the main.py file, we can basically use this file to only instantiate instances, meaning creating data that will represent something to Python. So this means that we can go ahead and import the class from the item file. We can do the same from the phone file, and then we can go ahead and do the stuff that we used to do. So we can say item.instantiate from CSV, and to verify that this works, we can also say print item.all like that. And if we want to run this file now to see that this works, then we can do that, and you can see that everything works just as expected. Now, just a quick side note, I'm not going to rely too much on the child class that we have created in the latest episode. To show the problems that we're going to solve in that episode, I'm going to rely more on the item class, so that it will be easier to follow and we will not complex things too much. Now that doesn't mean that I do not recommend using child classes or something like that, but it will be just easier to show you the cases that I'm going to show in the parent class. So that's why, for example, I deleted temporarily the import line of the phone class, and I just came up with a random item instance that name is my item, and the price happened to be that number. I did not specify quantity because we have a default value. And now after this line, you can see that I override this attribute by the string of other item. Now the expected result is not going to surprise anyone, because we see other item when we print this attribute. But we might want to ask ourselves, is that a behavior that we always want? What if we want to restrict our users to change the attribute of name once the name has been set up in the initialization, meaning in that line? Well, that's something that we might want to achieve for critical attributes like the name of your instances, and in our case, the name of our item. So what we could do, we could actually go ahead and create read-only so-called attributes, meaning that we have only one opportunity to set the name of our item, and then we cannot touch the value of that anymore. So what that means? It means that we can set up this in the initialization, and we should have errors if we try to override the value of that. Now that's also known as encapsulation when we talk about the principles of object-oriented programming, which I will be focusing more on the future episodes. But now let's go ahead and see how we can come up with read-only attributes, how we can restrict our users to override the attributes after the initialization of our instances. Okay, so on the left side we have the main.py file, and on the right side we have the item.py file, which we are going to work on, and inside the class I'm going to create our first read-only attribute. Now the way that you can start doing this is by first using a decorator. And if you remember from the previous episodes, decorators are like functions that you can pre-execute before another function. So I could go ahead and use the property decorator and then go ahead and create a function, and here's the exact location that I could set up the name of our read-only attribute. So for testing reasons, let's go ahead and call this read-only name, something in that kind, alright? And then I will open up and close parentheses, and this will obviously receive self because it's going to be belong to each of the instances. And now for testing purposes, let's only go ahead and return a random string like a 3 times, alright? And then, now that we have done this, I can go to our main.py file and try to access this property. Now pay attention that I'm going to call those properties and not attributes. So I'm going to go here and I'm going to try to print item1.name. And now that I have wrote name, pay attention to the differences in this dropdown. For read-only name, we receive a totally different icon here on the left side, which stands for a property, where in here we see the F letter, which stands for a regular field. So if I was to try to print that and run our program, then obviously we will receive the expected result. But if I was to try to set a new value for the read-only name, say that we want to change this to something like that, then you're gonna see that PyCharm is going to complain about this. And even if we try to execute that, then we will end up with an exception that says attribute error can't set attribute. So that is how read-only attributes, so-called, are working in Python. You can create those by using a property decorator before your functions and return whatever value you would like to return. Now the biggest challenge here is going to be converting the name attribute that we actually have, which is happen to be exactly here, into being a read-only attribute, and that is going to be a little bit challenging, but let's go ahead and start working on that. So first things first, I'm going to delete those 3 lines because we are not going to use this property anymore, and I'm going to scroll up a bit and work underneath this constructor here. So you might think that converting the name attribute into being read-only, meaning a property, is as easy as doing something like first using the property decorator and then go ahead and say def name, then receive self as the parameter, and then use something like return self.name because we already have the self.name assigned to the self object. But actually doing something like this is like saying to that class, hey, from now on you are going to have a name attribute that is going to be read only. And that is straightforward the effect of the property decorator. So I'm going to leave a comment here that is going to look like the following. But if you remember, we try to set the self.name into a new value inside our constructor. So you can see that this action is illegal because we have a read-only property here. So when you go ahead and create a property with the name of basically name, then you are no more allowed to set this value anymore. You are only allowed to have access to see this back in whatever instance you will create. So that is why if I was to hover my mouse here, then we're gonna see an error that is saying property name cannot be set. So the Pythonic way to doing this workaround to get over this is using one underscore before the name of our actual attribute name that we assign to the self object. And by doing this, we earn a couple of things that are quite important. So first, let me add here an underscore and just use something like that. And then now I need to go to my property function, meaning the property attribute, and I'm gonna need to add here the double underscore as well. Because first things first, I go ahead and set up the value for my single underscore name into being equal to the value of this parameter here. And then I go ahead and use one more read-only attribute that I intentionally give the name of name, and then I return self._name. Now I can go back to my main.py file and see what effects those lines are having right now on our instances. So first, I can go ahead and set a name for my item, and I can access to the name of this item by saying something like item1.name. So I don't really have to go ahead and use item1._name because that is going to be a little bit ugly and not convenient, because accessing attributes with always an underscore before is not nice for each of the instances that you look to access to their attributes. Doing this one time inside the class is going to make it okay, but trying to access those attributes outside of your class, meaning from the instances, is not going to turn it into too much pretty. So that is the best way to overcome such a thing. And now if I was to try to print that, then, let me fix that quickly, by item1.name and run our program, then you can see that that is working. And now let's go ahead and also see if we can set our name into being equal to another thing like that. See if that works. You can see that I cannot set that attribute. But however, I can still see this underscore name from the instance level. And that is maybe something that you look to avoid. It could have been a lot nicer if we could somehow prevent totally the access from this underscore name in here. So the way that this is achievable is by adding one more underscore to the attribute name. Now this might remind you something that is called private attribute if you are familiar with programming languages like Java or C#. That is pretty much the same behavior of using the private keyword before your attributes in those kind of programming languages, where it has different principles when it comes to object-oriented programming. So to sum up, if you add one more underscore to your attribute names, meaning you use double underscore, then you basically prevent the access to those attributes totally outside of the class. So let's see a simulation of that. So I'm going to minimize the terminal and I'm going to go to my item.py file. And besides using here single underscore, I'm going to add one more. And then I'm going to change this to double underscore as well. And now if we were to go to our main.py file and let's use here item1 dot and try to basically use double underscore and try to access to name. Now you can see that I don't even have an auto completion from my dropdown because I don't have access to see this attribute from the instance level. And that is something that you look to achieve when you want to have a clean read-only attribute, and that is the way that you can do that. So if I was to try to print this, then that's just going to complain about how it does not have the attribute of double underscore name in this instance. And again, if I was to remove those double underscores, then I will just access it as a property, meaning as a read-only attribute, and that is exactly what I look to have here. Alright, so now that we got the idea of that, then we still might be curious about how to set a new value for the name attribute. Now obviously using the property decorator is going to turn this into being a read-only attribute, but there are still some decorators that will allow you to, however, set a new value for this property of name. So let's see how that is achievable. So obviously that is not going to work because it says can't set attribute. So what we can do is we can use a new method where we can declare that we'd like to also set a new value for this attribute that we named name. So the way that that's going to work is by going to our class here and using here one more method with a special decorator. Now this decorator is going to look like the following. So I'm going to refer to the name because that's the property name, and then I'm going to use the dot setter. So by doing this, then I basically say, hey, so I still want to set a new value for that name, although that is a property, meaning a read-only attribute. So now if I was to go down and say something like def name, and this would receive self, and as well as one additional parameter, because the additional parameter should refer to the new value that I want to set to that name. So I will receive a parameter that I could name something like value, and then inside here I'm only going to set the new value for our double underscore name, because if you remember, when an instance tries to see the value of name, then we basically return self.double underscore name. So when a user will try to set the name again to a new value, then it should execute self.name equals to value. And by doing this, I basically allow our users to yet set a new value for name. So now let's show what effect those three lines are going to have in our main.py. You can see that now the errors gone. I can now go down here and use print item1.name, and that's going to work. You can see that I have other item. So this means not only I can set a new value for my underscore name, so-called, in the initialization, I can also do that later on if I only use this convention in here. Now those getters and setters thing are always confusing in no matter programming language you work, so I will do a final summary of all what we have learned until this point. Alright, so using add property will basically give you a control of what you like to do when you get an attribute. And also by using this, then you basically convert this attribute into being read-only if I was not implemented these setters in here. So you can see that now when I commented those out, then this line is going to have some problems, because by not doing this, then I basically say that, hey, name is read-only, you cannot set that. If I was to again uncomment those back, then I will have the control to set this attribute to whatever attribute I'd like to. Now by using this statement here, basically getting the attribute, then I basically call the bunch of codes that are being executed in here. So whenever I use item1.name, then Python says to itself, okay, you try to get that attribute. So I will go ahead and try to execute all the lines of codes that are here. So that is what exactly happening here. And to show you that, then I can just use a random print function here that will say you are trying to get name like that, then you should see this line being printed right before what the actual value is, because at first we print you are trying to print the name, and then we return the self._name, so it prints that over here. So that is what's happening when you try to get an attribute. But when you try to set an attribute, then Python says to itself, okay, so here you try to set an attribute. So because you set an attribute, then I should go ahead and execute the code that is inside here, because that is the setter of that attribute. So that is why when you go ahead and use this decorator, then you should always receive a parameter, because the other item is going to be passed as an argument to that parameter. It is very important to understand that. And that is why I can only allow myself to use one line of code that will say self._name is equal to the new value that you try to set. And to show you that, again, I can go here and say print you are trying to set. And this line should appear just before this print line, because at first I try to set a different value for name, and then I just print it back like that. Okay, so if I was to run that, then you can see that at first we see the line of you are trying to set, then right after it we actually see whatever item1.name is equal to. Now the reason that the value is set, it is because we set it over here, and then the next time I try to get the value, then those lines are getting executed. So that is the life cycle of getters and setters, and that is the way that it works. By having the control of whatever you'd like to do when you set a new value, you can also restrict it. You can go ahead and do some conditioning, or you can go ahead and raise some exceptions if you don't like the value that you receive. Let's say that you want to restrict the length of the characters for the name of that attribute, alright? So that is something that you can do. You can actually go here and say if len of the value is greater than 10, then you'd like to raise exception that will say something like the name is too long, something like that. And then you can say else, and then you can execute the line that will be responsible to set that value. So intentionally I'm going to leave it as it is because the length of that is 9 characters. So we should not have any errors. But if I was to add here 2 more characters like that and execute it, then you can see that we are going to receive an exception that will say the name is too long. So that's how getters and setters are working in Python. You now have all the knowledge that you need to play around with the different attributes and manage them the way that you would like to. So I believe that after the information that you received in that episode, you have everything that you need to manage your attributes successfully and play around with it, and as well as coming up with rich classes that will have multiple attributes, and then you can set up special behaviors to those attributes, and also you can decide that you'll not like to force to receive those attributes in the constructor. You can decide that you can delete some parameters in your constructor, and you can say that you will not like to assign those to the self object immediately when you create an instance. So whatever you would like to, you have all the tools to play around with how to manage your attributes. Object-oriented programming comes with 4 key principles that you should be aware of, so you will understand how you should design your large programs so it will be easier to keep developing it. And I'm going to talk about those principles, which are encapsulation, abstraction, inheritance, and polymorphism. So the first principle will be encapsulation, and we will talk about this a little bit. So encapsulation refers to a mechanism of restricting the direct access to some of our attributes in a program. Now notice how we did a great job in the last part where we implemented the encapsulation principle on our project. So pay attention to how the name attribute could not be set to a new value before it goes through some conditions that we set here, like the length of the character being less than 10 characters. So restricting the ability to override the values for your objects within your setters is exactly what the encapsulation principle is about. Now, to even give you a better example of encapsulation principle, then we are going to apply similar things to an additional attribute, which is going to be the price attribute. Now, if we take a quick look in that program that I have just executed, then you can already see that I have the ability to directly set this object into whatever number that I like to. Also, negative 900 will work here. So that's probably something that we look to change. And the way that we can change that is by implementing some methods that will restrict the access to this price attribute. So it could have been nice if we could have 2 methods that will be responsible to increment this price by some percentage amount, and the same goes for the discount. Now, if you remember, we already came up with a similar method that looks like apply discount when we talked about class attributes, because self.payRate multiplied by the actual price is actually going to change this attribute being decreased by 20%, because pay rate is set to 0.8 if you remember from the previous episodes. So let's go ahead and continue designing this price attribute to totally support the encapsulation principle. So first things first, I'm going to convert this price into being a private attribute, so it will be a great start avoiding to set this price directly like we have seen previously. Now I'm not going to just add here double underscore, besides I'm going to grab this whole thing and I'm going to right click, and then I'm going to say refactor rename, and then I'm just going to rename this price by setting it like that, double underscore before that. Now doing this is actually going to refactor this change on the entire class where we try to access the price attribute. So that is a great thing, so we don't really have to change everywhere. So once I have done that, then if we would also take a look in the apply discount, then you can see that we have this being set to a new variable name that we came up with. So now that we have done this, then let's go ahead and create a property. So we will have the ability to access the price attribute temporarily being only read only. So I'm going to say add property, and then I'm going to say def price. Then I'm just going to return self.price. So that's a great starter to restrict the access to the price attribute, because now we still have access to the price attribute, and then we cannot set that. So you can see that if we were to try to access item1.price, we will have some errors, but we can just access the actual value of that where it comes from the initialization. So that's a oh, actually I see that we hit an error that says recursion error, and that's probably because I did not add the double underscore in here by mistake. So that's actually a great exception that we came across right now. You can see that we are going to hit recursion error, maximum recursion depth exceeded. And that happened because I tried to return the price without the double underscore. So if we try to call the self.price, then it is going to try to call this function. And if we try to return that, then it's just going to loop over it again, and in some time it's going to fail with the recursion error, as you see. So that's actually a great exception that we see now. And if you see this exception in your object-oriented programs, now you know how to handle it. And if I was to come back now to main and execute that, then you can see that the expected result is here. Alright, so now that we have done this, then let's go back to our class and try to work on our methods that will modify the attribute of double underscore price. So I will actually cut this method from here, and I will just put that right under the property price that we came up with, so we will have a cleaner look. Now, first things first, you can see that we have the apply discount, and we will also like to come up with apply increment like the following. And we would like to say here self.double underscore price is equal to self.double underscore price plus self.double underscore price multiplied by some value that we can receive as a parameter. So we could actually receive a parameter that we could name increment value, and then we could just multiply it by that number. So now that we came up with this, then let's test this up. Okay, I'm going to go back to my main.py, and then I'm going to call item1.apply increment, and then I'm just going to pass in 0.2. So we will increment the value of 750 by 20%. Now the next time that I access the item1.price, we should be able to see the actual value of price, which should be 900. And if I was to run that, then you can see that the price has been incremented to 900 as expected. So that is exactly encapsulation in action, because you go ahead and you don't allow the access directly to the price attribute. Besides, you modify this attribute by using methods like apply increment or apply discount. Now the same will happen if I was to now go ahead and use item1.apply discount. And you can actually modify this method in the way that you like to, but this currently refers to a class attribute that we use here. So this should also again apply a discount of 20% to the 900 price. We should be able to see 720, and that's exactly what is happening here. Alright, so the next principle that I'm going to talk about is called abstraction. Now, abstraction is the concept of object-oriented programming that only shows the necessary attributes and hides the unnecessary information. Now, the main purpose of abstraction is basically hiding unnecessary details from the users. Now, by saying users, I basically mean people like me or you that are going to use the item class to create some item objects. Now we can see that now we have a new program here that has one item object that its name is my item, price being that number, and we have 6 from this item. Now we can also see that I came up with a method that doesn't really exist, which is called send email. So that method at the end of the day should send an email to someone that would like to decide about this item, and it will send info about how much money we can earn by selling all the items, and maybe about some more info that is related to this item. Now, sending an email is not as easy action just by calling it with that way, because in the background email sending has to go a lot of processes like connecting to an SMTP server, and as well as preparing the body of the email with an auto message that will display some info about this item. So as we can understand, we have to go through a lot of new methods before we go ahead and just call a send email method. So to simulate that, then I can actually go ahead and say send email. So I will just create the method that is necessary. Temporarily I will use pass. Now, as I said, we also have to go through a lot of other processes, so it is a great idea to create methods for each of those processes, like connecting to an SMTP server like that, and I will just say pass because we only try to simulate the idea of abstraction here. I'm not really going to send an actual email to someone, I'm just simulating an idea of sending an email. And we will also have to go through preparing a body for an automatic mail, prepare body, right? And then I can just return a formatted string that will say something like hello someone. We could receive this as a parameter as well. And then we can say we have self.name 6 times, right? So it should be 6 self.quantity times, like that. Then I can say regards Jim shaped code. So that is just a very simple email that we can send to someone. Now you can understand that we have to call those methods inside the send email. So simulating that will be self.connect and then self.prepare body. And probably we also need to go through sending it, right? So I can just say something like send here, then use pass again. Now you can see that those methods at the end of the day are only going to be called from the send email, because those are just parts of the email sending process that is a bigger process that we divided into multiple steps in this class. Now the biggest problem is we will have access calling those methods from the instance, and that is exactly what abstraction is about. Abstraction principle says to you that you should hide unnecessary information from the instances. So that is why by converting those methods into being private methods, then we actually apply abstraction principles, and that is achievable in Python in a way which, I'm going to be honest, is not too much convenient, but it is achievable by adding double underscore. Now again, in other programming languages, this is achievable by having access modifiers for your methods like private or public, and I'm talking about programming languages like Java, C#, etc. So if we were to convert those methods to private methods by only adding double underscore, then those only could be called from the class level, meaning inside the class. So if we were to try to access it, then you can see that I'm going to have autocompletion, meaning I will have the ability to access those methods. And then I will just do the same for the other methods. Now this error comes from here because we did not really specify some argument. I'm just going to add an empty string. Now if I was to go back to our main.py file, then you're gonna see that we are going to have some troubles. Even if I'm going to try to access it with a double underscore, I'm not even going to have an autocompletion. And the reason for that, it is because that is a private method. So you really have to think about your methods if you want to make them accessible outside of your class, meaning from the instances. And that is exactly what abstraction is about. You want to abstract the information that is unnecessary to call it or to access it from your instances. Okay, so inheritance is the third principle of object-oriented programming. Inheritance is a mechanism that allows us to reuse code across our classes. Now, that's something that we have totally designed well throughout this course, because we came up with more classes that are child classes of the item class, where each child class represents a kind of an item. Now, pay attention how I changed the import line from phone import phone, and I use the child class of item which we came up with, which is called phone. You can see that I'm passing similar arguments, and I can still use a code that is implemented in the parent class. If we were to execute this program, then we are not going to receive any problems, because phone uses all the methods and the attributes that it inherits from the item class, which is exactly here. And if we remember, we designed the send email method in the parent class, and we can use it from the instance of a phone. And we can also do that for the rest of the methods that we came up with that really affect some of the attributes, like in the encapsulation part where we applied the apply increment method that receives an increment value. And if we were to test this, incrementing the price by 0.2 and then printing item1.price, then we should see 1200. So if we were to print that, then you can see that that is exactly the result. So that is mainly what inheritance is about. It is about reusing the code across all the classes, and that's exactly the scenario here. And the beauty behind that is that you can come up with more child classes that will represent kinds of items like laptop, keyboard, camera, everything that you think about, and then you can just modify specific methods that you'd like to according to the kind of item that you have. So that's perfectly describing what inheritance is about. Alright, so the last principle that we have now is polymorphism. Now, polymorphism is a very important concept in programming. It refers to use of a single type entity to represent different types in different scenarios. Now, a perfect example for this definition would be some of the functions that we already know that exist in Python. Now, just a quick side note, polymorphism refers to many forms, poly being many and morphism being forms. So again, the idea of applying polymorphism on our programs is the ability to have different scenarios when we call the exact same entity, and an entity could be a function that we just call. Now, as you can understand, polymorphism isn't something that is specifically applied to how you create your classes. That is actually something that refers globally to your entire project. And in the next few minutes, we are going to see some bad practices where polymorphism is not applied, and we are also going to see where in Python polymorphism is perfectly applied. So a great example of where polymorphism is applied is in the len built-in function, because the len built-in function in Python knows how to handle different kinds of objects that it receives as an argument, and it returns you a result accordingly. So as you can see in here, if we were to use the len built-in function in a string, then we will receive the total amount of characters. But if we will do this in a list, then we will not receive the length of characters of this entire expression in here. Besides, we will receive back the amount of elements that are inside this list. And to show you how this is going to work, then I'm just going to run this program, and for sure the results are just as expected. So as the definition of polymorphism says, it is just a single entity that does know how to handle different kinds of objects as expected. Alright, so now that we understood that the polymorphism is applied everywhere in Python, especially in the len built-in function, let's also understand where it is implemented on our project here. Now you can see that I try to call the apply discount method that is never implemented inside the phone class, and the fact that I can use it from the item class, it is because we inherit from this class, and that is the basically reason. Now, if I was to go back to that main.py file and run this, then you can see that that is going to work because the apply discount is a method that I can use from the inherited item class. Now, that's exactly where polymorphism is also in action, because polymorphism again refers to one single entity that you can use from multiple objects. Now, if I was one day to go ahead and create more kinds of items, meaning more classes that will represent different kinds of items, and from them to call the apply discount method, that's also going to work because the apply discount is a method that is going to be accessible from all the kinds of objects. So that's exactly why you might have heard about the terms of inheritance and polymorphism together combined. Now, to show you that, then let's try to create one more class that is going to be identical to the phone class, right? I'm going to create a keyboard file, and then I'm just going to say here class. You know what, before that, let's go to phone and copy everything from here and paste this in like that. I'm going to get rid from those lines, and I'm just going to leave the init as it is. I'm going to change the class name from phone to keyboard, and I'm also going to delete that attribute that we don't need, broken phones. Alright, so now that we have this, then I can actually go ahead to my main.py file and use one more import line that will say from keyboard import keyboard. And then I'm going to change this to keyboard. We'll replace this name just to make it more realistic. Then I'm going to run the same program. You can see that this works. So that's again exactly where polymorphism is in action, because we can use this single entity from different kinds of objects and it will know how to handle it properly. Now, by saying handle it properly, then I basically mean you can have the control of how many amount of discount you want to apply inside your classes now. Because if we were to go to keyboard and use a class attribute exactly like we used in the item class, which was pay rate, then we're gonna have full control for all the discounts that are going to apply to the keyboard. And to show you that, I'm going to attempt typing in pay rate, and you can see that I even have auto completion because overriding in the child class, that is legal. Alright, so I can just say pay rate is equal to 0.7 and that will be it. Now I have the same discount amount for all my keyboards. If I was again to run the main.py file, then you can see that the results are just as expected. We see 700. So that is the beauty behind inheritance and polymorphism together. And the same will go for sure if we were to decide that we'd like to have 50% discount. So it will only take from me to go ahead and say pay rate is equal to 0.5 and that's it. So I hope that you understand about polymorphism a bit better now. Now, just a quick side note, polymorphism is perfectly could be implemented by using abstract classes, and that is just the identical way of using interfaces in other programming languages like Java. Interface is a way that you can implement how a class should be designed, alright? So it is like a template for a class, and that is achievable by using abstract classes, which I'm not going to cover in that part. But again, polymorphism, like I said, is a term that is implemented in different areas in the whole Python programming language. So I hope you had a great time learning the object-oriented programming course. Now you have a lot of tools that you can go ahead and try to implement by yourself on your projects, which will really help you to take you to the next step as a developer. See you next time.